I just said preachers.
But I don't hear it yet, bro.
What?
What's that from? Show.
She's like, how are you feeling? What? Are you okay? Are you okay?
What movie? Right, listen.
Star Wars. Truman Show.
He's beginning to believe.
Truman Show.
Yeah.
Star Wars.
I don't know.
Star Wars. Star Wars.
Another line from the same movie. I should have taken the blue pill.
Matrix.
The Matrix.
Oh yeah, that's when he's like fighting the agent, and then he like stops and like does the whole cool thing,
Yeah.
like dust flies off.
That is a killer whale. And if you look at a killer whale skeleton, there's a leg bone buried in the muscle of the tail. Isn't that interesting? Why would there be a leg bone buried in the muscle of the tail of a whale?
Because it used to be an alligator.
Hey, is it connected to the spine?
Nope. Disconnected. It doesn't have any function.
Are you telling
Just
me
real little.
it's just like a random bone in the fat?
It's not random. It's right in the location where legs would be.
Like they used to be legs, now they're not.
It's a suggestion.
Evolved.
Darwin called it a vestigial structure. That whales came from organisms that walked on land. And after they took to the water, the legs became smaller and smaller and disappeared. We call those vestigial structures. Humans have those too. You have a tailbone, but you have no tail.
I broke my tailbone.
There's a lot of other ones.
I broke my
So we're going to talk about this,
Same thing.
the theory of evolution by natural selection. For a long time, people have thought that organisms might change, that species might change over time. This goes all the way back to the Greeks. And there might be some evidence that even before that, some people thought that organisms might change. And the idea of organisms changing is called evolution. Evolution is simply the idea that organisms change form over time. They don't remain the same. And Darwin certainly didn't come up with that. What Darwin came up with was the theory of how evolution works. And Darwin called it natural selection, and he became very famous for it. And I'll show you that theory and all the different evidences of the theory and that sort of thing. Now again, a lot of the stuff he says is contrary to some of the stuff you've heard from religion. But this is a science class, and I teach you stuff that has been learned through the scientific method. And that's what happens in a science course. So you feel free to believe what you want. Look at, and you'll have to, of course, answer on the tests what we are learning here in the class. But take in the evidence, make up your own minds. That's what life is all about. There is a lot of interesting stuff in evolution, and if you sit there and say, I'm not going to pay attention to any of this, you're going to miss a lot of the ideas and conversations that will go on for the rest of your life, and you won't know what people are talking about. So it is good to understand what Darwin did, what went on the voyage of the Beagle, and what's going on the Galapagos Islands. I mean, if you never paid attention to what people talk about there, you wouldn't know what the Galapagos Islands were about. So some interesting things here to learn from these next few chapters. This is the voyage of the Beagle. Darwin was a young naturalist. A naturalist is a person that studies nature. And he got on the Beagle. He wasn't much older than you guys. He was 22 when he got on the ship. And this ship was actually doing a mapping mission. It was going to the coast of South America to map the coast of South America. And whenever you take a boat on a mapping mission, you bring a naturalist with you. A naturalist is a guy who knows a lot about nature. He can tell you what you can eat and what you can't eat when you land on the shore. Because they didn't take enough food with them to last them the whole voyage. This voyage lasted 5 years. There was no way to take 5 years of food with you. So when you land somewhere, your naturalist gets out and says, don't eat those mushrooms. Those will kill you. And they go, oh, good thing we brought him along. We won't eat those. You can eat those, and you can shoot those, and stay away from those. And so that's what the naturalist did. So Darwin, as he was voyaging around South America here, they saw a lot of things, and eventually they end up, or they stop by the Galapagos Islands, and that's where he saw a lot of the things that that interested him and got him thinking about evolution. And we'll study those, and I'll show you, because I went there last summer and took a lot of pictures. Were y'all all here for that presentation I gave?
Yeah.
I'll show y'all some of those pictures again. Here are just some of the things that he saw. Darwin. Remember the sedimentary rock? Darwin knew a lot about fossils too. He had just read a new book that came out by a geology guy named Lyle. Talked about fossils. Those are the seagoing iguanas on the Galapagos. Those are the Galapagos Islands.
Did you go to all those first?
No, we went to these right here. Right here. All of those. We didn't go to these. We didn't go there. And we didn't go up here. These are active volcanoes that are blowing up like right now. And it's the entire island is just black rock.
Like as we speak.
One of them went off in 2005. I mean, they're like dribbling out lavas sometimes, but when they really explode, it's a pretty big event. They're cool, a bunch of cool little islands around. This is one of Darwin's finches. Darwin was famous for his discussion of finches. He found 13 different species of finches on the Galapagos. And he thought going in that you get a group of islands out here in the middle of nowhere, they probably all have the same kind of bird on all the islands. Why wouldn't there just be one type of finch on all these islands? They're pretty close together. It turns out to be 13 types of finches. They all differed in their size of their beaks, in the shape of their beaks, and what they were able to eat with those beaks. Darwin later found out, for instance, that the island that had the real thick-beaked finches, the only real thing to eat on that island was nuts that had to be cracked open with heavy beaks. So all the birds there had heavy beaks. And a different island would just have insects to eat. And all the birds there had little thin, long beaks that could reach in holes in trees and get insects. And a different island had something else with a different beak. And so what Darwin reasoned after looking at all of this was that maybe that the finches came to the islands a long time ago. And depending on what island the finches were living on, the beak changed to be able to take advantage of whatever food was available on that island. So that's the idea of evolution. When you hear change and evolution, that's the same thing. There's Charles Darwin. He got off the Beagle when he was 27 years old. And he started thinking about his ideas of natural selection. That's him at an older age with one of his kids. And he never published his ideas until he was 55 years old, I think. Because he was afraid. He was scared to say that organisms change because it went against the church. And he thought that he was going to become an outcast. And there have even been people who said stuff against the church that ended up dead. Famous astronomers like Galileo, have you heard of him?
Yeah.
He was put under house arrest for the last 30 years of his life because of what he saw with his telescopes. And when he said that the world wasn't the center of the universe, that upset a lot of people, and he was arrested. There's another guy named Giordano Bruno that said Galileo's right when he sees through his telescope. The Earth does go around the sun. And they burned him at the stake for it. And he was right. So Darwin was afraid to publish his works. And he didn't do so until another guy, there's Darwin again, until another guy named Wallace sent Darwin a theory, an idea he had. Wallace came up with a theory of natural selection, the same theory that Darwin had. And Wallace said, maybe organisms do change, and this is how they change. And who should I send this idea to see if it's right? I'll send it to who's supposed to be the best naturalist in the world, Charles Darwin. So Wallace wrote up his theory, he sent it to Darwin. Darwin opens the mail one day, and there's Darwin's theory of natural selection, written by Wallace, this guy 1,000 miles away. And so Darwin decided to publish at that point. And Darwin and Wallace's theory were both sent in to the Linnaean Society, and they were both credited with natural selection. But it's only Darwin that's famous now. Wallace really isn't that famous.
Well, it should be.
Yeah, he should be. You're right. Here's some info.
It was a world in transition. The Industrial Revolution was just beginning. In Britain, it seemed all the world was opening to these engines of change. It was a time of big ideas and big men. There was Erasmus Darwin, a prosperous country physician, a published poet, a free thinker, and a champion of the new technology.
Darwin's granddad.
His son, Robert, another man of influence and girth, followed him into medicine when Robert's second son was born, February 12, 1809. It was assumed he would be part of a third generation of country physicians. But Charles Robert Darwin was happier in the woods than the classroom. He preferred to be outdoors, hunting, bird watching, collecting, exploring.
Charles was in and out of country houses and barnyards, and he saw how people selected the best cattle, the best pigs, and the best horses, and bred from them to improve the quality of the stock. Later on, Charles would call this artificial selection. His own mother kept fancy pigeons, so Charles could see right at home that from a common rock pigeon, the kind you find in Trafalgar Square in England, you get all kinds of extraordinary breeds, Jacobins and Pouters and Nuns and like.
He abandoned his medical studies and wound up at Cambridge University, where he was to study for the ministry.
And that's when it first occurred to him that he could make his name in natural science. He could make better beetle collections than any of the beetle collectors. He came here to the River Cam and scouted along the banks and looked at the trees and pulled beetles out of the bark. He bested a lot of them.
Knowing full well that he was more interested in collecting bugs than saving souls, two of his professors recommended him for a voyage around the world. The refitted 90-foot warship named Beagle was to map the South American coast. It was the turning point in Darwin's life. Intended to last 2 years, it was 5 years before the Beagle returned. 5 years of collecting, observing, exploring, and writing. The most important stop for Darwin was the Galapagos Islands. This relatively young, isolated archipelago 600 miles off the coast of Ecuador was a naturalist's dream, a laboratory of evolution. In a feverishly busy 5 weeks, he followed seagoing iguanas and tracked tortoises that seemed to vary from island to island. He collected 13 different types of birds that all turned out to be finches, and 3 species of mockingbirds. The animals must have come to the islands from South America in the distant past, but these creatures varied remarkably from their mainland ancestors.
Darwin was amazing. He was 27 years old when he got off the Beagle. His notebooks were were bulging with data about all the places he had visited. He had enormous collections.
In addition to adding to his beetle collection, he gathered 1,500 species preserved in alcohol, 4,000 skins, bones, and dried specimens, crates and crates of fossils. He returned with 3,000 pages of notes on entomology, geology, paleontology, and zoology. He was the toast of London's scientific community. Even his father was finally impressed.
Huh. Let's look at the theory of natural selection that Darwin came up with. After all this research he did, Darwin figured, here's how things change. And this is your essay. If you roll the essay on this chapter, you're going to have to first write about natural selection, which is 421 in your book. Turn to 421. It's all summarized there very nicely. There are 4 points that you have to make when you're talking about natural selection. And Darwin used the idea of natural selection to explain the long neck of the giraffe, for instance. He said there's a reason why the giraffe has such a long neck. It wasn't created on Earth with a long neck. It came from organisms that were like horses with regular sized necks. And the neck grew longer over time. And Darwin used natural selection to explain how. And here's the 4 points of natural selection, and I'll go through this somewhat slowly. Number 1 is called variation. Variation is the idea, and I'm going to skip this theory. This is Lamarck's theory, which we learned about in AP Bio, which was wrong. Variation. Early giraffes probably had necks of various lengths. Again, there were some giraffes with short necks, some giraffes with long necks. The regular variation of a population. You could say the same thing about humans. Some humans have short necks, some humans have long necks. Right? I've seen some people with real short necks. And you're like, what's up, short neck guy? And he does nothing, just enjoying my short neck. So, first Darwin noticed the natural variation of populations. We now know where the variation comes from. Do you remember when we studied genetics?
Yes.
Where do you get variation from? There's 4 major ways of variation. Sex is the main one.
Yeah.
If you put your genes in with genes from a totally different family, you get a new creature with a whole mix of genes. Yeah. And that could, the creature could be born with a neck different from either parent. Sex is the major way you get variation. There's 3 more ways.
Selective breeding.
Wrong?
That's a way to change to change organisms through time. That's kind of like a way to select, to spark evolution. What were the other things as far as genetics go?
The 4.
Remember what happened during prophase 1?
Crossing over.
Crossing over. Remember, crossing over switches genes around. That's a way to get variation. Mutation is another one. Mutations cause variation. And then, I don't know if you remember independent assortment during meiosis, when the chromosomes line up and they can go either way. Yep. Anyway, that's where we know where the variation comes from now. So there is variation amongst organisms. Number 2, heritability. Heritability. Variations are inherited from parents. Tall sunflowers produce tall sunflowers. Short sunflowers produce short sunflowers. So there is heritability. The kids, although they do have variation, they tend to look like their parents more than like someone from a completely different family. you have a tendency to look like your parents, but there will still be some variation. So these two things are important in passing along genes. Number 3, overproduction. Darwin noticed that a lot of things die. You know what? 2 adult roaches will produce 1,000 eggs. And 1,000 baby roaches born from them. Do all of those baby roaches survive to adulthood?
Maybe 5.
Let me ask you a question. If the roach population is staying the same, how many baby roaches will survive to adulthood?
1. 2.
2. To replace both parents. For each female, it is 1. For each female, it's 1. For the male and the female, it's 2. So there's an overproduction of offspring. That means 998 baby roaches die and only 2 make it. And finally, number 4, reproductive advantage. What Darwin says is that if there's an overproduction of offspring and only 2 of the babies are going to survive to adulthood and all the rest of them are going to die, the 2 that make it to adulthood probably have some reproductive advantage. Probably have something that allowed them to survive where everybody else died. Perhaps they were dark colored so they blended in so you couldn't see them as well. Perhaps they were faster. Perhaps they had a better way of getting food. There's some kind of variation gave the 2 that survived some advantage. And they're the one that makes it to adulthood. So, let's say they just happen to be born, the 2 that survived happen to be born darker colored. So they blended in better and nothing could see them to eat them. Then if those 2 make it to adulthood, and they mate with some other roaches, or they could maybe mate with one another, then they have kids that are dark too. And over time, the roach population becomes dark and able to blend in. Do you see how that works? That's a change. Let's look at it, whoops. Let's look at it from the point of view of the giraffe. A bunch of giraffes have necks of various lengths. The short-necked giraffes die. That's a dead giraffe. The long-necked giraffes survive. They reproduce. And the next generation has long necks like their parents. Some with even longer necks than their parents. The ones with the long necks end up surviving. The ones with the shorter necks dying. If this goes on for thousands of years, you eventually just end up with long-necked giraffes. A lot of students I've had in the past have looked at this and they've gone, Mr. Willis, there's 2 questions I've got. Mr. Willis, 1, why don't they just eat the dead giraffe? I get that question.
Because they're vegetarians.
They're vegetarians, they don't eat things. Second, they say, well, Mr. Willis, why don't they just eat the grass? And I say, yeah, you're right, they could just eat the grass. This isn't a very good picture. Actually, giraffes evolved in areas where there wasn't much grass. Most of the food was on trees. So, I don't know why they put grass in this picture. Let's just pretend most of the food was on trees. Another question I get is, Mr. Willis, how do the baby giraffes eat? Do you know? They're mammals.
Mama's giving food.
Yeah, the mother, they eat milk from the mother until they're tall enough to
Okay,
get
well
their own
then why couldn't tall giraffes just like break off a branch?
They could, but it's not in their genetics to help one another that way. You got to fend for yourself.
What
If you're a giraffe.
their kid?
It's not the long.
What if what?
It's their
It's not the
kid.
long.
Even their kid, they quit helping after a certain age. And they let them go on their own, and if they happen to have short necks, they're not going to make it. Yeah?
In the third picture is a little tree. Why don't the little guys eat that tree?
I think that's supposed to be a far-off tree.
Oh.
I think.
It's very misleading.
Yeah.
Looks like a small one.
Okay, so let me go through this with you. Here's natural selection. Here we go. We have a variation of necks. Some with short necks, some with long necks. Here's our giraffe population. The short-necked ones, Anthony, hang with me. The short-necked ones died.
Whoa.
And are removed from the population. The long-necked ones are left. They mate amongst one another. And they create the next generation.
I know, right?
And now the next generation is born. Still with some variation. Many of them having long necks. There are still a few short necks. Guess what happens to the short-necked ones? They die. The short-necked ones died. They're removed from the population. The long-necked ones survive and have kids. Again, there's variation. Some with even longer necks than their parents. Some with even shorter necks than their parents. The ones with the short necks die, are removed from the population, and this just continues year after year after year, culling out the short necks, long-necked ones surviving. And if you do this for 1,000 generations, 10,000 generations, 1,000,000 years, you end up with the long-necked giraffes. Whoops, wait, let me go back one. You end up with the long-necked giraffes, and if you compare them to the original population, the necks are longer. The giraffe population has changed over time. That's evolution. Change is evolution. We see examples of evolution with every single species. Every species on Earth shows examples of evolution, how they've changed from their ancestors. Where do we see the evidence? We see it in the fossils. Remember the way fossils are deposited. I talked about it last time. Older fossils are buried deeper. Newer fossils are further up. And so you can compare. If there's a giraffe fossil here and a giraffe fossil here, that's the way giraffes looked a long time ago. That's the way giraffes look more recently. You can measure the neck lengths. It's a pretty simple thing to do. And if these tend to have longer necks than these, it looks as though the neck has changed over time. Darwin saw a lot of fossil evidence. Ooh, there's me.
Really?
At the Painted Desert in Nevada when I was 10 years old. I remember taking that picture. My dad kept saying, "Go closer to the edge." This is a big drop-off. It's like a big cliff. This is looking way down into the canyon. That's me. And he said, "Go closer to the edge." And I was like, "I don't want to go closer to the edge." And so I was like almost crying right there when he did that. There's me and Dad on the same trip.
Look at that stylish car in the back.
How about the tie? The 70s tie. They used to wear ties like that. That's not our car.
That's my room in the back.
My old car.
There's us at Yellowstone. There's my older sister and my mom.
Why is your mom like creeping in the back?
I don't know, but she wants to get away. That's before my younger sister was born. Or no, she was born, but she was just a baby.
That's your sister.
There's my pet.
Wow, that was
This is a glyptodon. Darwin saw these in South America. He didn't see these living creatures, he saw fossils of them.
Okay.
And he looked at them and he said, "Hey, it looks a lot like an armadillo, but different." And that got him to thinking that maybe that armadillos came from these things. There's the glyptodon on top that we only find fossils of, and there's the modern armadillo on the bottom.
What's on its tail? No, it looks like
A mace to hit things with.
from Super Mario's brother. What's his name?
What are you talking about?
Bowser.
There's me next to a glyptodon fossil that was in a museum in Nebraska.
Is it that big?
Yeah, that's how big it was.
That glyptodon was not like the picture.
Yeah, they came in different types. One thing about the glyptodons is They're different from the giraffe. The giraffe got taller with longer neck. Glyptodons got smaller.
How big are those things?
They're big.
Look at him.
That's me next to him, and I'm about 6'5".
Right?
There's a Mylodon. You know what that is?
Bigfoot. Bigfoot.
That's the ancestor of the sloth. They were huge.
That's it.
How big about?
They were about 15 feet tall. About as tall as the ceiling and another 3 feet.
You're serious?
Yes. There's the modern day sloth, the ancestor of the Mylodon. Or the modern day, this is the modern day sloth. Its ancestor was bigger and they grew smaller. We see organisms getting smaller over time often when there's a lack of food. A lack of food doesn't favor a large individual, it favors a smaller individual. We often see it on island groups, islands where the weather patterns change and there's not as much rainfall and not as much food, and organisms who are smaller are favored because they don't have to eat as much. And so on island groups, there have developed many small species, and one of them is the sloth. This is smaller than us, it's maybe that tall. Darwin saw this is called a Patagonian hare, and its ancestor is the
Wombat.
Graham, I swear.
what do we call these things?
Capybara?
Guinea pigs.
Guinea pigs. Thanks. Guinea pigs.
Capybara. You're wrong.
Capybara may be a name for the same sort of thing. I don't know. This is a giant tortoise that Darwin saw. And the giant tortoises Darwin saw, almost all of them had regular necks, but on one island they all had long necks. So this is kind of like the story with the giraffe. On the island where the tortoises had these long necks, the only thing to eat were tall cactuses. And Darwin thinks they evolved the long necks to be able to eat the tall cactuses. All the short-necked tortoises died out on that island. It's just on one island. And there's one of the
Finches.
the finches. Again, there were several species.
Video
What's
footage.
that crow? Looks like a crow. A crow?
Show you this video footage and I'll show you some of my pictures.
The video. Birds.
The Galapagos Islands, off the coast of Ecuador, are a living laboratory for the study of evolution. Galapagos means tortoises in Spanish, because these islands were first named by the early Spanish explorers for the giant tortoises that inhabit the islands. A major food source for the tortoises is the young pads of the 15-foot tree-like prickly pear cactus. Another unusual animal that lives on these cactus pads is the world's only marine iguana.
Whoa.
How did tortoises become giants? How did cactuses become tree-like? And why did iguanas become adapted to feeding on seaweed underwater? The high percentage of unique species in the Galapagos Islands is common in remote island groups. This phenomenon has been studied repeatedly since Charles Darwin first encountered these remarkable islands. The Galapagos Islands are the only place on Earth with a tropical penguin, a flightless cormorant, and a large number of finch species, which inspired Darwin's theory of natural selection. The only explanation for the existence of high numbers of endemic species on the Galapagos Islands is that more familiar continental ancestors of tortoises, finches, cactus plants, and lizards arrived somehow by chance and then could not leave. They were forced to stay, survive, and breed away from their ancestral population, and consequently evolved into the unique species that live there today.
So let me go through. I know y'all sat through this whole thing during when I did the assembly, but I do want to show some of you the pictures again and some of the highlights of it. I'm going to skip some of the things. Okay, it's being slow. Ooh, it's a long one. Ooh.
Man, Beth, you want to load it?
Yes. Getting closer. Getting closer. How many years will it be before we never have to wait anymore?
Never.
Yeah. Yay!
Oh.
No way! Okay. Hurry up.
You're kind of impatient sometimes. I wonder how you were on Christmas when you were little.
I want to open them. You have to wait.
That's like Meredith on a daily basis.
Why are you comparing
Oh
everything
my
to
gosh,
Meredith?
Mr. Willis.
Yeah.
Mr. Willis.
Yeah.
I was over at Meredith's house one time and she starts whining and at the same time her mom and I were
Hold
like,
on.
shut up!
Tom Willis. Bennett
Really?
Brush is not
I
arrived.
was like, I don't
Okay.
care.
It's a horrible one.
Okay. You see these sea lions, they're all over the Galapagos.
So cute. I love swans.
Here's the Galapagos right off the coast of Ecuador. We flew into Ecuador, then we went to the Galapagos. We flew into Quito, Ecuador. And this is just a bunch of pictures of Quito. It's kind of a dirty place. Yeah, Theo was the volcanologist that showed us the volcanoes, and I'll go through the volcano pictures really fast.
Was that you throwing up the game?
Were you blowing at a hut, bro?
Yeah.
I was blowing at a hut.
I want to see that one.
It's like the story in the two little pigs.
See? I was blowing down the straw hut.
Oh, I thought you were blowing the hut. I was like, what?
Horsies.
True.
There's Charles Darwin, and I'm a little bit. There's Darwin's book. I have a copy of The Origin of Species. I don't know where it is. I hope I didn't lose it because I got it as a present, a birthday present. There's one of the giant tortoises.
That's in the wild or in a habitat?
That was in a habitat. We did see them in the wild, but you can see the long neck there. That's one of the long neck ones. They keep them. They keep a lot of them in a habitat because they're almost extinct. The voyages across the Pacific would often stop at the Galapagos to pick up tortoises. They put the tortoises in the hull of their ship because the tortoises would be able to survive for 6 or 8 months without being fed or drinking water. Because the Galapagos have a dry season. And they've all adapted to that dry season. It'll go for 8 months on the Galapagos without rain. And so all of that's why there's cactuses everywhere, because they can store water. And these things can store water in their bodies. And so the ships, the sailors would come by, put 400 giant tortoises in their ship, sail across the Pacific, and they'd kill the tortoises one by one and eat them. And that's how they lived. And so the tortoises started to go extinct on the islands because they were slow to reproduce and they can live up to 250 years. And
Sweet.
So here we are. There's me in the Galapagos.
Cool, bro.
There's Super Teacher Joe. This guy right here was pretty amazing teacher.
Did your shirt say brothers?
Tracy. Panthers. To school, I guess. A bunch of shops there. Oh! Sea lions were everywhere.
Was that Theo down there?
Wasn't that
That's Theo.
Wasn't that the teacher guy?
Oh, Theo.
Josh, super teacher?
Super teacher, yeah.
Yeah, that's Josh. There's me reading next to a sea lion.
Are you reading a bedtime story?
Reading popular science. Waiting on the boat. There's a blue-footed movie. There's the boat we were on, the Yolita.
How did you get a picture?
They rode us around in these little boats called Zodiac. See those little boats there? And we would ride back and forth because these boats couldn't come close to the islands. They had to anchor offshore. And then we'd ride the little Zodiacs around. So I took that when I was on one of those Zodiacs. That's the shark head right there where the anchor comes out. It's pretty cool. Oh, there it is. Whoa. There's the captain. I jumped on the bridge to take his picture, and he's like, "Get off the bridge!" I was like, "Okay, sorry." This guy was our nature guide on the trip, and he was incredible because he could do every call of every species there. Like, he would do a call, and all the birds would look, thinking it was another bird.
Really?
Yeah, he was amazing.
Awesome. Really,
and all the other guides that came around, this guy, yeah, his name was Washington. This guy trained almost all the guides there. So whenever we'd pass another guide with another group, they'd say, "Oh, hey, Washington," and they would tell us that this guy was the best. They gave us the best guide because we were a group of teachers.
You're a super teacher. Tell me.
How long were you there for?
10 days. So here's these things laying out. These are the land iguanas.
It looks like it's dead.
Did not. You weren't allowed to touch. These things would lay out to warm up. Would lay out on the sand.
Was it hot or cold?
It wasn't that hot. It was about between 75 and 80 degrees every day.
Nice.
This is the area where these islands are. There's a cold current that comes up from South America, that comes up from the South Pole, basically. It comes up and reaches these islands. So this is right on the equator. But that cold current brings cold water. So the water there is really cold. You had to wear a wetsuit to go diving. It was so cold. And that cold water keeps the islands cool. It's not like 100 degrees. It never gets above like 80 there. So it's actually cooler there than it is here. These are called Sally Lightfoot crabs. They were everywhere. I'll continue this tomorrow.